So that should give you a hint on the second one. You need to pull out a -4 out of the second group. So this one has to be a 2x minus 3. So the only way I can get there is to pull out a -4. So remember that you can try to multiply that back in. It should end up being whatever this is. So a -4 times a 2 is a -8. -4 times a -3 is a +12. So that is the first kind of steps of the factoring. So remember that we are factoring out the common factor, which is this 2x minus 3. So you write it down once, and then you're left with x squared minus 4. Now the x squared minus 4 factors. It's a nice, neat x plus 2 and x minus 2. Is this an even, odd, or neither? Anybody got a guess on it? Or what we talked about yesterday? So what? Why?
First off, you said like the next ones are going to be neither yesterday.
Oh,
but second of all, it has an odd and has an even.
Thank you, Jess. So that has an odd power, that has an even power. If the powers are even and odd, they switch, then you cannot end up having symmetry. So we're really not going to have any symmetry, right? So it won't have rotational, nor will it have y-axis. If you're an even function, what type of symmetry do you have?
Symmetry.
Just normal symmetry. Is what? Y-axis. So if you have an even function, it is y-axis symmetry. If you have an odd function, it's called rotational symmetry or origin symmetry. Now, find the roots. So this is the part, like on the quiz yesterday, I said factor the following and then find the x-intercepts. And so in order to find intercepts, you have to find the roots first. So I need to see this work. Some of you guys wanted to skip this work and go straight to writing down your intercepts. But you need to do this. All right, so I'm going to add the 2 over here, so x is equal to 2. I'll subtract the 2 here, get x is equal to -2. And I will add the 3 here, get 2x is equal to 3. Now I'm going to divide by 2, so x is equal to 3 over 2. Right now I have 3 roots. Well, it matches up with my degree 3, so I don't have any imaginary, since those are real. If this was prime down here, and this was a plus sign, then these 2 roots would disappear, and I will only end up with 1 real root. In these 2, it'd end up being imaginary roots, and we would have to be able to find that. Okay? So complex roots are coming up. So the graph, if this is a plus sign, this graph ends up looking something like this. All right? Well, take that back. It looks something like this. Why did I pick that? Because that's really a positive intercept. Why did I pick that? Okay? I had it on the negative side. So that would be the case if that was prime. We would end up having 2 imaginary roots. Imaginaries always come in pairs. Okay? So in this case here, I have 3. All right? 3 possibility of real roots. And I could end up with 1 real root and 2 imaginary, or I could end up with 3 real roots. Now, we ended up with 3 real roots. So that scenario is not really the scenario that's going on. So let me remove that. And let's go ahead and write these as intercepts. If I ask for things in intercept form, yes.
What makes the root real or imaginary?
Do what?
What makes the root real or imaginary?
Imaginary would mean that in this case here that this would not factor, okay? And so when that doesn't factor and we go to solve it, you will find out if they are real or imaginary through the work that you do, okay? I know these are complex in this case because when I subtract the 4, I get x squared is equal to -4, and I take the square root of a negative number, it gives you an imaginary root. So this turns into 2i, and I have the absolute value of x over here. So x is equal to what we call plus or minus 2i. So those do not exist on the real number system, all right? They exist in what we call a lateral plane, a plane that's completely different. So for instance, this is your x-axis. I'm sorry, this is your x-axis, and this is your y-axis, the way you guys use it, okay? If I take a sheet of paper or a plane and I draw a plane out here, you have 3 dimensions, okay? Then the 2i is here and here. There's a -2i and there's a +2i on either side of this axis. So when we get into the complex numbers, we can talk about that a little more. If I've got time, I'll show you the video here so you can understand that in a little bit more. I don't think I've got it ready and fired up for you to see, okay? So I'll make sure I have it ready. Maybe tomorrow we can watch it, okay? Then we have to give you a better understanding of what imaginary numbers are and where they do exist, and that we do have something that it's the wrong name. They're like, oh, they're just there. Like, we're imagining they're there, I guess, is what they're supposed to do. Now, so that would be the case. All right, that's how you find that. All right. So it would have to be when we're taking the square root of a negative number, that's where you're gonna get your imaginaries. Okay? Not all prime, okay? If this not all primes, sometimes these will factor and give you irrational roots with the square roots. So those are still real solutions, even though they're irrational. They're not pretty solutions like we're giving you, okay? So back to this here. So I've got my roots. If I ask for intercepts, and this is the thing on the test, when you have an intercept, guys, I need to see ordered pairs. I said to said here, what is the y-intercept? And this has happened so many times. You guys gave me 12. You didn't, that's 12 is just a number. I said intercept. It needs to be 0, 12. I'll give you your quizzes back here in a few minutes so you can see what you did right or wrong. That happened a lot. This one here would have been 3, 2, 0. This would have been -2, 0, and 2, 0. So those would have been intercepts. Okay. All right, now we already talked how many solutions there are. We already talked about the degree. So let's go ahead and plot these points. 0, 12 is off the chart. It doesn't matter where you pick it. I'm just going to pick it and then label it. 0, 12 is somewhere up there. Okay. Let's go ahead and plot the other points. I think we had -2, 0, +2, 0, and 3/2, which is 1.5. Now, so if I put 1.5, it's pretty dang close to that, correct? So this is what I proposed. This is what we did in my other classes. We've done this before. We've got that one scaled. I'm just going to put here and write down -2, 0 so I can scale that. I'm going to go ahead and put a dot here and a dot here, make this one 2, 0, and make that what? You have 0. So therefore, I've got a little space in between so they're not so close together, all right? It will help you with your drawing, all right? So, but the only way you can do that is you've got to label your points. If you're going to use the graph and try to get it to be right, I got to see that you are talking about those particular points you found, okay? So the next thing we're going to do is draw this. Now, as you can tell, we got to work from left to right. So I'm going to start here and go down, and I don't go anywhere. All right. What was the reason? Why did we fail that? Why did it not Why did it not go through? Remember, we got to go through each gate, right? Well, again, this is what? A cubic, correct? If I have a cubic and I throw a negative number in there, what would you get? What if you threw negative infinity in there? What would you get if you take negative infinity and you cubed it? Okay, Bella? You would get negative infinity, right? So as we go, if we put in, this is x, if we let x equal negative infinity, if we go all the way to the left, how far, which is at the very end of it, right? So if we go towards negative infinity, then this thing gets y is equal to negative infinity. So it's going down. As we go to the left, it's got to go down. Does that make sense? Does it make sense, Tom? So as we go that direction, we put negative infinity, and we cube it, we would get negative infinity. What if I put a positive infinity in there, DeMonte? What would you get? What? Yeah, you get positive infinity, so that would mean that the y is going up. So as we go to the right, we should go up. So if we're going way, way out here, we're going up. Does that make sense? So this starts down here and finishes up here. Now we know that we've got our maze to walk through. We know where we're starting from. So we're going to start over here, go through that point. We got to turn and come through this point, come down through this point, and then go back up. And look where you are. Okay? So what I was just going over was what's that called? What's in green over here? Anybody remember what we're talking about? The end behavior. Your end behavior is based on, again, if you're a cubic, if you're a quartic, or a quintic. So the only way I can switch this up, the only way I can make this a little bit different is if I put a negative sign in front. Now, what happens? If that is flipped over, it flips your graph over, right? That's a reflection over the x. Well, think about this. Negative infinity cubed, as Bella just said, was negative infinity. And then we're going to switch the sign on it. So there's an extra negative, which makes it positive. So now when we go to the left, we're really going up. All right? So your y values are going up. So that sign in the front is going to make the difference on which way the end behavior is going. Okay? Again, as we said, there is no symmetry here. There's no rotational symmetry. All right? Your graph can look different. It's not going to be, more than likely, this is not going to be a maximum. It will probably go up here like this, then curve, we come back down through, and go back up. Okay? It is a function, so it will pass the vertical line test. Unfortunately, mine will not. So that's wrong. As you can see, it kind of bends in, so it doesn't. I'd have to draw a little bit better now. All right. Let's take a look at your homework. The new sheet I gave you yesterday, 4.7. So if you're absent, it's the one on the very right of the table over here. Braden needs one too. Did you pick one up? Yeah. No, it's not a packet. It was a single sheet. 4.7 is a single sheet. We had to retype it up. It was wrong. It was printed wrong. So if you were absent yesterday, you'll need to pick one of these up. All right.
She was like, psych.
I raised my hand.
Yeah, no, she didn't hear. She didn't see you, nor did she hear you. All good. All right. Questions from homework 4.7. Yes, Whitley.
Do you know the
Number 8.
Yeah, it's on the.
All right, number 8. Complete the square. Okay. This is, again, a skill that you have to be able to do. This is the toughest skill out of all of the quadratic stuff you have to do. This is the toughest. So if you're having problems with any of the other stuff, you need to come in here and tutor in the morning. And some of you guys are not making it. We're taking advantage of that opportunity to get 15, 20 minutes in. All right, and make sure you have your stuff ready to go and ask the questions. All right. In this one here, complete the square. It is x squared minus x plus blank minus 3 minus blank. First thing you got to do in order to complete the square and put into vertex form. Vertex form, I need a y equals in the front. All right, as well. First thing I do is I'm going to isolate that constant, the -3. What was after that? Do you know what's next? Parentheses. Good job, Monte. All right, he's right on it. You're going to have 2 sets of parentheses you're going to draw, right here and right here. Good job. What's the next thing we do, Maddox? Look at your x squared. Is your x squared clean? Is there a number in front of it? And we need to yank out? And the answer is no. So at this point in time, we don't have to separate anything from the x squared. All right, we're looking for numbers that have to separate. So like none of these actually. All of these actually have a clean x squared and all of those. So in this case, this is the first 2 steps. Now I gotta fill in the blank. How will I fill in that blank?
Square.
You're going to half it and square it. All right. So we're gonna half it, square it. What's half of that number? Which is 1. That is just a half. You take whatever that number and divide it by 2. Okay. And we're gonna square it. What is 1/2 squared? 1/4 is correct. Now, the hard work's done. All we have to do is draw that set of parentheses that Monte said to draw. Take this and make that an x. Take this, make that a 1/2. Take the sign and put the sign right there. And the little 2 goes on the outside. You're going to take -3/1 minus 1/4. The work now is this. That's the work. And I already kind of preset it up. I already wrote it as 3/1 because I can't take a number, all right, it's a fraction. This one is divided up into 4 slices. Like you've got a pizza here, okay? It's only got 1 slice of 4. This is 3 whole pizzas. We can't work with that. We got to take the 3 whole pizzas and slice it up into 4 slices each. All right. If I have 3 whole pizzas and I cut them into 4 slices a piece, how many slices do we have? 3, 4, 1. 12 is correct. The math involved is just taking this and multiplying by 4 and this by 4. All right, that gives you a -12 right here. And there is a -1 right here. And the way I look at that is -12 minus 1 is a total of -13. So -13 and the slices still stay the same. It is still at 4 because we sliced them all up that way. Then you just got x minus 1/2 and a little squared there. And look what we have. Vertex form. I know it's going which direction? Is it opposite day? Then which way is it going? Right 1/2. Okay, right 1/2, then what? Down 13/4.
And then he
Because
said
I was like, what's up,
He
man?
said up, and then I said down. And
I was kind of confused. I was like, there's a seesaw in here. All right, somebody's trying to break themselves. That's what, I mean, that's the rides we had when we were kids, man. We had seesaws. It was always fun.
my sister got on with me.
Yeah. Oh yeah. You used to try to get it and see how high you could pop up in the air and get air. That was always fun as a kid.
Riverview, the one with the big
And you get
seesaw.
down there, you jump, and then you're just trying to, and then you'd always have a bigger kid who'd come in, and he would sit, and then you get two people to sit on it to get the fulcrum just right and get them all the way up, and then jump away, and he'd hit the ground.
In Riverview, we have a big seesaw that has like.
I don't know how many busted teeth come out of seesaws too, because they're always that you get so much in the air, and then your face goes right through the bar, and you're holding on the best you can. Oh. There's this kid I remember went up to school in elementary school. He came in. He was on the playground, and I remember the ambulance coming and picking him up and taking him away. And he comes in, and he's got cast on both arms and both legs, and he's coming in and he's trying to learn his alphabet. You know, and he's trying to count and learn his numbers, and because that's what we did in kindergarten, what you guys do now at home before preschool. But I remember him being cast up, and it was so funny. People had to feed him. I was like, "What's wrong, Keith? You know, like, what'd you do?" He goes, "Well, I was playing on the monkey bars," and he was up on top of them, and he jumped down, and he landed, and he broke both his legs and both his arms, and he's like,
I don't push the kid off the monkey bars for stepping on my
"That's it, dude." Yeah, that kid was always messed up, so. I think after that, it was like people picked on him all the time.
My nephew hurt his finger. He went around flipping people off, and I was like, "Oh, why are you flipping me off?" He's like, "What's that?"
Yeah, exactly. That's what happened to me. Standing in the water, drinking the water, in the water line, and the kid showed me his middle finger, and so I started playing around with it too, and then I got in trouble.
My grandmother from
Second grade, Miss Sanders.
my grandmother.
She was an old woman. I sat there, she goes, "Is there something wrong with your finger?" I was like, I wanted a lot so bad. And I was like, "No, man." She says, Jacob was showing me his, so I was showing it now. And she was like, "Going," and then she had my mom, to my mom, "Get this to your mom." And I was like, I got in trouble over this. I was like, going, "Really?" I didn't get smacked in the behind over it, but I did get scolded. By one of the teachers that you like impressionable, like it was so. Taught me a lesson. Always do it first. All right. Because it's the second person. It's always like, yeah, I come up and I punch Demonte, and then next thing you know, he comes back and he retaliates. He's in trouble because I just sit there and like, I wasn't doing anything. And Monty just come up and hit me. Like, you saw me attack me. Like going, but he did it first. Like, there's no excuse. Like, you know what I'm saying? So you just, all you have to do is just like, when you get that lick, you just go like, just remember, I've got friends. We're going to take care of you. You go so crazy. You grab that toothbrush, you start whittling it.
We're turning into prison inmates now, doing that stuff.
You got your shiv. You're like, all right, now.
It's like the girls that smoke them crack sticks in prison.
I tell you, I'll take care of you later. You got that one. It's a free one, but that's all you get. All right. Any other questions over your homework? Yes.
1F.
1F. This one is still an enigma, right? So when we're working with this right here, we're talking about 1F. It says write the factored form of the equation. right? I guess there's a couple ways you can do it, Gavin. You could find the vertex, which in this case would be what, positive 3, negative 2. And you could write your vertex form and go y is equal to x minus 3 squared minus 2. And then know there's a vertical stretch of 2 on it. And you could go ahead and convert that and expand it into standard form. Okay? And the other way is looking at your intercepts. This intercept happens to be what? X is equal to 2, and that one is x is equal to 4. Well, those are intercepts. Those are your roots, right? So we can take that and write it backwards into factors. So in order to do that, I subtract the 4, go backwards. So x minus 4 equals 0, so that is one factor. And this one ends up being x minus 2, which is the other factor. So I will get x minus 2 and x minus 4, and I have a y equals, and then I have to look for the vertical stretch or compression that is out front, whatever is adjusting this. And in this case, Gavin, we normally go over 1, up 1, which would be here, but we're stretching it up 2, correct? So therefore, I have to put a 2 out front. All right? As I said, you could take this and do the x minus 3 times x minus 3. That will give you x squared minus 6x plus 9. I had several people put a minus 9 right there yesterday. I had a lot of people put a 3 right there instead of a 6 when you're expanding that. All right. Then I would multiply everything by 2, which means I will have to double everything, which would be 2x squared minus 12x plus 18. And don't forget the minus 2 over here. I had some of you guys forget the minus 2. So you get 2x squared minus 12x plus 16. Now I got to factor that. You see what I'm saying? I would have to take that into standard form and then factor that. So either I look at my intercepts and go the quick way, or I'm going to go through a pretty torturous. Yeah. But this one's still solvable. I just pull a 2 out, right? I'm just going to show you real quick that it does work. Okay. And so then I just need to factor this portion. And to get 8 is 4 and 2, right? And don't forget the 2 up front. There's your factored form, or what we call intercept form. All right, there's 2 names, intercept form or factored form, because you can find your intercepts really quickly by setting them equally to 0, all right, and writing the order of pairs. Okay? Yes, that one is kind of brutal to go that direction, but it is possible, yes. Number 9. Ms. Green, you got a question? Yes, you may. All right, number 9. In number 9, I have a square root. I'm going to take 72 and break it down to 8 times 9. Remember that? And 8 breaks down to a chicken foot. And 9 breaks down to 3 and 3. And then my x is 1, 2, 3, 4, 5, 6, 7. Y is 1, 2, 3, 4. I have a square root. So I'm circling what, guys? Pairs. Now, this will give me a 2 times 3 out front, and x to the third and a y squared. 2 times 3 is, you can do that in your head, which is really 6. And everything that is not circled stays underneath, which is 2 in the x. Now, this is a square root. A square root cannot be negative when it comes out, so we have to ensure that we don't end up with crazy answers. So the odd ones get after days. Next question. again, some of you guys, need to learn how to study, and some of you guys, again, you are limited because you got work, band, and whatever it may be. Remember that if some of the stuff you kind of read off pretty quickly, highlight the things that you don't know how to do, make notes of the ones when you find out the correction, like Gavin found out how to do this one. He needs to make sure he makes notes of that. So when he practices tonight's homework, and he goes, wait a second, what was that? What Coach Love said about letter F, how to go through that. There's two processes. I'm going to go for the easy process. You need to make notes of how you got there, so that when you're reviewing your notes, then you can do it again. It's not enough just to write it down. Some of you guys aren't writing down the understanding of it. When I'm in college, and I know how to do transformation form, and I'm looking at this problem, I'm not going to do that. Professor says, here's what we're doing. This is the section we're doing. He doesn't even assign homework. It just says we're doing it unit 1. And the test is on such and such date. I take his notes and I write down all the examples. I write down what I need to learn on those, and then I go practice on my own. I open the textbook and I find problems and I try the odd ones because the answers are in the back. Most college books actually have all the answers, but sometimes you don't. So you have a resource I didn't have, which is like Mathway or, there's all different types of math programs that you can use to try to get the answer. So if you attempt a problem, you can see if the answer is. Generally, you get in study groups and you talk to somebody and say, hey, Monte, how'd you get number 3? They're like, all right. See, now this is an absolute value graph. There's no more of a parabola. So something happened in it. So let's take a look. So if I have this one here, it's going left 1, down 5. Down 5, 1, 2, 3, 4, 5. I'll show you what he's got on his paper. I'm going to show you because this is a common thing. They're thinking that in this case, I have a vertical compression of 1/2, correct? And so you're thinking that, well, this is what I did with the absolute value graph, so that's what I do with this one. No. So in this case here, remember, what's the parent function?
0, 1, 2,
0, 0, 1, 1, 2, 4, right? So you're going to put 0, 0, 1, 1 over 2 up 4. If you need another one, you can go 3, 9, correct? 3 up 9. You have those points. Now we compress it by 1/2. We cut the distance in 1/2. So that's not 4, it's 2. That's not 9, that's 4.5. We're still at 0, 0 here. We're at 1/2 right here, 1/2 right here. -2 up 2, and this one's going to be about the same point there. Okay? That way, you graph it, it looks like that. Okay? You see that? Yes. Number 7. Find number 7. Number 7, we got to complete the square. X squared minus 36x plus blank plus 4 minus blank. Parentheses is the next thing you do. Add your blanks, draw your parentheses. Take a look at your x squared. Does it have anything on the x squared? No numbers on the x squared. So all I have to do is fill in the blanks. Yep, half of 36 is 18. So I'm going to get 18 squared. Oh, 19 squared is 361. Remember it? 324 is correct. 324. So this factors down to nice, neat x minus 18 squared. And then I'll put that together, gives me negative 320. Make sure you have a y equals in front, and you can box your answer. There's a weird, crazy number. But practicing your perfect squares. That's a pretty good one. I liked it. Any other questions? Let's did all your homework already, man. All right. Hopefully, you learned something through your homework. Again, you've got to find your process on how you're going to do, because obviously whatever you're doing right now for some of you guys is not working. Okay? Some of you guys, yes, it's working. Continue your process. If it's working for you, I don't say switch it up. Okay? But for those who are, all right, struggling, you need to change your process. All right, so let's take a look at your notes. We're going to finish up these notes today and start a new set. We have a quiz on Friday, just so you guys know. Yeah, here in just 1 second. All right, so I'm going to give you some information that's important, especially if you're in a band or if you're planning on going with your brother or sister or cousin, whoever, just to watch because you want to go to Indy with your friends, but not participate in the band. So, I mean, some people do that, right? November. So we have a quiz on Friday of this week, and we will have a test on the 11th, okay, which is next Thursday. So the band won't be here, but you guys will need to make up that test. All right. Pretty much it. All right, what number are we on? 13? 11? Hey, you guys are way back. Number 11. So let's complete the square. We did practicing this, right? We did 2 of them this morning. Now this one's a little bit more difficult. Monty's already got his blanks written down. He is trying his hardest to keep up or stay in front of me. So I'm going to try to catch him. All right. Draw your blanks.
My friend's car broke down before I finished school today.
Well, why does that affect you?
Because I was switching out with her. She was
Oh.
driving.
Okay. I was sitting there going, what? Yeah, it's just like my neighbor's car broke down, so I couldn't come into work. Yeah, that's the way it said.
No,
I'm sorry, I was just. That was
no,
the way it
she's the
said.
one that was driving me, so
Oh,
that's
yeah.
kind of the problem. Couldn't get here.
That would make more sense. Yeah, well, all my cars are broke down, so I was trying to use my neighbor's car, and his car broke down this morning, and I couldn't get it. Now that makes sense. All right, so draw your blanks. What's the next step? Parentheses. Draw your parentheses. You got that, plus? P stands for plus or parentheses. All right, now, once you have that, then you've got to look, is there something in front of your x squared? Yes, there is. So I need to remove it. Whatever I remove off of this x squared needs to be put over here. Right, Emma? -2 goes there. -2 goes there. Now, I'm going to go ahead and finish the work in here. This plus 10, if you want to go ahead and put the plus 10 down, it will not be touched through the whole process. Okay, that constant stays that constant because it's a constant. All right? We'll constantly leave the constant alone. I'm pretty consistent on that constant. All right, now. Stop crowding more. Just like, all right, so there's a blank here and a plus blank here. That is always going to be plus blank. That is always going to be a 10, and it's always going to be blank there. So removing the -2, I get an x squared here, and what do you think the number goes in here? Plus 4. Now, what he did here is he was going to say negative, but then he went and checked it again and said, wait a second, a -2 times a +4 would give me a -8. Okay? And that's what I would do is check to make sure those two work out, because that's what you're supposed to have. Okay? If you are in this scenario, then you're almost there. What we're going to do now is fill in the blanks. Half it, square it.
I'm close.
That's right. You got to remember half it, square it. What do we take? What number do we take half of?
4.
The 4. We're going to take the 4 and cut it in half and make it a 2. Then you're going to square it, which is 4. The whole idea here, guys, I'll just go ahead and show you what you're really supposed to get. You're supposed to make this a PST, so it will always factor to the same exact thing. That is the design of this, is trying to make this happen. I say half it, square it like this because we're going to factor into x plus 2 squared. So to save you a little bit of trouble and speed up the process, you just put an x here, a plus sign, a 2, and put the little 2 on the outside. The -2 goes out front. All right, got the front end. All I got to do now is the back end. Now, there are no fractions in this, which makes this really nice and neat. We already know what that is, right? There is a negative. I forgot that minus sign. All right. Okay. That is a double negative. So I got negative. Guys, the reason this turns into a what? Plus a positive, correct?
Mm-hmm.
I want to show you real quickly here that, remember, we have to, whatever we add, we have to subtract. We can't change the problem. So this -2 really makes this a -8 that we put here, right? Which means that this has to be a +8 over here. It has to balance. If you left this as a minus, now we're down -16. We've made it too low and it doesn't work. So we're going to balance it out. So this is +8 plus 10, which is 18. And there is your final answer. Okay? And that is in vertex form. All right? Let me clear this off here, and let's go ahead and graph that sucker. Which way you moving it?
18.
Yeah. Left to up 18. Most of you guys are getting that now. I'm going to tell you right now, I was really pleased on the quiz when most of you guys got to that section, asked for description. You guys put that down. Okay, even some of the ones who didn't get it the first time through, we were working on it. Now, over here, again, if there's a negative all the way to the left, that is an ROX. So you guys need to put an ROX on the left side. The 2 is a vertical stretch of 2. Now, even this. Now, some of you guys are getting your left and right mixed up. It's still happening. I get people go, all right, left 2.
Maybe they're just one soup.
That was wrong, Justin.
That's not left.
Well, it's true.
All right,
You can't make
so
those jokes.
left 2. Now, here's the question. Up 18. Is it on the grid?
No.
Up 18 is not on the grid. So either you can count by 2s if you choose to, but one thing you've got to do, the most important thing, is wherever you make your intersection, that is your vertex. And since the vertex is not on the grid, right? -218 is not on the grid, or correct? So you have to label it. So you need to maybe put an arrow and put -218. Show me that that's where the vertex is. That is a must. Okay? Because I don't care. I mean, you can use 8 or 9. I counted by 2s. But in this case here, it really doesn't make a difference. You still have to label it. All right, now you got it labeled. You've got your vertex. This has a reflection, so we know we're opening down. So it's going to be over 1, down 1, over 2, down 4. So it's not going to be a V, right? Monte, you're done with V's and it's just a U. All right? Now on the final exam, you might see an absolute value. You might see a V. The only way that graph could work is if it was like 1.5. Because that's an absolute value. Okay? Now, so the next thing I'm going to do is I already got the reflection done. I've got the left. I've got the up 18. The only thing I do now is stretch it. I got to double that distance. This distance here is now doubled. And that one, I'm going to go instead of 4, I'm going to total of 8 away. It's easy to go ahead and find the other point on the other side because it's symmetric. Yes.
For my graph, I used the y intercept, and then I used the corresponding point, and then I modeled the x.
Yes. And that's what I would do here is, in this case, what she is saying, what Whitley is saying is that she went up here and used that point, which is 0, 10, which is the y-intercept. She went ahead and on here somewhere, she graphed it. Oh, wait a second. I can't use a vertical stretch of 2. That's the point. Sorry. My green graph is incorrect. I know it's flipped upside down, but in this case here, it's scaled wrong. That shows me my y-intercept is what? 0, 1, correct? This is wrong. Thank you, Whitley, for pointing this out. This is wrong because in this case here, I'm counting by what? 2s. So in reality, I'm going over 2, not down 4, but over 2 at 2 down because that's a total of 4 if I count it. Let me back this up, okay? Let me erase the graph and the purple dots and the red dots. Get there. All right, now I'm going to keep the vertex there. Now, because I have scaled it, I cannot use the traditional graph, right? That's what I'm going to try to get at here. So Whitley has pointed out that there is a y-intercept that we can use, which is 0, 10. So what I propose is that you know it's going to open which way? Where this sucker open? Down, correct? Mm-hmm. So draw your graph. Then we're going to plot that point. What's that point? That is the y-intercept. Label that point. Okay? We have another point over here. What's that point going to be? 10. But remember, it's the corresponding point to it. It is -4 because you double what? The axis of symmetry, which is -2. And that's probably enough points for me to determine that you know what you're doing. Okay? And I counted by 2, so this is pretty accurate. It's not completely symmetrical, so it should be here, only 2 away. But again, if you label it, I'm going to be okay with it. Okay? So make sure you label it.
But you don't the x values too.
Vertex is -2, 18. Do what I could have.
Because if you
You
do it
don't
on
have
the x values and the y values, then you could technically just do 1, 1, and
Correct.
2, 4.
Yeah, and that's almost too much for a lot of students. But you're correct. All right, now, I got to think of Kenny. All right, domain. It's all reals. Okay.
I don't know what y'all are talking about, but I heard that.
Exactly. That's the whole. That was what. That
That
was
was
really
the
what I
whole
was
point of
talking
the
about.
conversation. Came
Actually, that's what I was really talking about, right? All right, so all reals. And what's your range? -50 all the way up to what?
Negative.
18.
Yeah.
Now it's a bracket here. Some of you guys are still doing a parentheses around that 18. Or you can do y is less than or equal to 18. 18 is the largest. Remember, it is the little monster is trying to eat the 18. Okay? Some of you guys are still messing that up. You're getting your inequality backwards. By this time, I would hope that you would have that inequality correct. But some of you guys are still making those mistakes. But that's okay. You guys just need to practice. I don't expect you guys all to have all the right answers. You're still young, okay? You make silly mistakes.
Yeah, like being friends with just.
Well, that could be, that could be detrimental. All right, now, so let's expand this. Now, the expansion of this problem is a separate problem within itself. Yes, that has transformations, and we can list the transformations, and we can graph from the transformations. That is not the point of what I want to do right now. At this point, everybody needs to expand this. Expand means to write into standard form. So I want to take the -3, and I'm going to put a bracket and do x minus 3 times x minus 3. Close my bracket and do a plus 3. Now remember, you're doing that information first. So go ahead, guys, and attempt this. Take your x minus 3 times x minus 3. X minus 3 times x times x. Outside and the inside. Right? Put our whole one together. The way you do it, again, you're going to take the x and the x, it gives you x squared. And then you're going to do the outside and inside. That gives you -3x, -3x. How much is that? Adam.
Is it less?
And then you're going to take the -3 times the -3. -3 times -3 is positive. Then you're going to take the -3 and distribute to each of those. And then last but not least, n. Anybody see the mistake you made? Make sure inside you have x squared minus 6x plus 9. Make sure you get that. And then -3 plus 18. And 3 times 9 is. -27 and then plus 3. And now add 20. We make 27. -3x. Minus what? Okay. No, they all have to be insert factor this. -3 and all this. Now take the -3 and just distribute each of these. 3x squared, -3 times -6. Hey, good job. Now take the -3 out of all those and start back. Good. Yep. Pull that -3 up. You do it. Take -3 multiply -3 equals this. After that. Pull -3 out of each of those. Start back. Don't worry about it. You can't have a quiz thing. I will. I thought maybe you might be cheating. You did. Yeah. You did. You were wasting. Questions? Good?
Yeah, that's what.
All right, so what'd you get? 3x squared plus 18x minus 24 is what you should have ended with. If you did not get that, then you did your order of operations incorrectly. Multiplication comes before addition. That +3 is the last thing you will touch. You're going to get -3x squared plus 18x minus 27 plus 3. That's how you get here. Then we're going to factor a -3 out since they're all involved in that. And it ends up with a nice neat x squared minus 6x plus 3. And that is 8. Oh, that's nice and easy to factor. Thanks to the one that was on the quiz yesterday, I think. Monte said he did this and he did this. What's new? Oh, you are. All right, now. We're working on notes for an example, I don't know, 13 or 14. All right, 14, I think. 12? No, yeah, you're right. It's 12. All right, example 12. All right, so in this case here, what do we do next?
Is it take the square?
We got to solve. How do you solve? What are we doing every single time in the morning when we do our openers or if we do a quadratic and we have factors? We set them equal. That's the one thing is you got to think of like, all right, got to set these equal to 0. So set the equal to 0, set that equal to 0. I'm going to add the 4, so get x is equal to 4. I'm going to add the 2, so get x is equal to 2. This -3 doesn't have anything. If it doesn't make sense, -3 equal to 0, that doesn't make any sense. So that's not going to be a thing. So in this case, you only have 2 answers. It's a quadratic anyway. You can't have 3 with a quadratic. We already talked about that. You have a 2, so the fundamental theorem of algebra says that if you got a degree 2, that means you've got 2 solutions. All right, now, 2 and 4. Go ahead and plot those points. Go ahead and draw that axis of symmetry because that is going to tell you x is equal to 3. It said the Goblins comes around and haunts this place. All right, now. Is that your impression, Mr. Thomas? All right, good job. All right, so that was impressive. All right, so you've got your x value, which is 3. And then some of you guys kind of got lost yesterday on what to do next. This 3 gets plugged into this factored form. So the 3 will go here, and the 3 will go here. You'll do the math on this. And I'll go ahead and erase this so I can have the room here. But 3 minus 4 is -1, and then 3 minus 2 is a +1. Don't forget your vertical stretch, which is -3. This is all multiplication. I had somebody add it once. But we're going to multiply all together. +3. So we get 3, 3. Guys, 3, 3 is right here. You can graph that. Where's your y-intercept? Well, we wrote it in standard form just a second ago, and y equals, that's your standard form, by the way. And you make sure it's got a y equals on it. 0, -24. If I want the corresponding point, and I told you it was going to happen on the quiz, and it did, didn't it? You want the corresponding point to the y-intercept? Well, the y value doesn't change, -24. What I'm saying is this parabola is opening down, correct? It's going way down here. Somewhere down here it's going to be crossing at 0.24. It's going to have a sister point sitting right over here, or a brother point. It's like a twin, all right? So on this, I didn't want to call Javonte's sister. All right, now, so in this case here, this would be 3 away, which would be 3 away, so it's a total of 6. So this is 624. You just take the x symmetry and double it, okay? Right? Max or min, what do you got? That is a maximum. That is the very tip top, which is a max. Again, you take this and regurgitate it backwards, which you go 3, and then write at x equals 3. If you want to do the cinnamon roll, you can. Just make the little A and then a circle around it. It works, okay? Some of you guys are really good at the cinnamon roll. Yeah, it makes me hungry. All right, now, for cinnamon rolls at least. Questions? All right, number 13. Ooh, what's wrong with this one?
There's a hole in it. We can't see the words. That's what's wrong.
Oh, there's a 4?
Yeah, there's a 4
Yeah,
there.
it's crazy, right?
Yeah, somebody asked yesterday. They asked me in, I think, B or C. They said, number 13. Can you show me that? So I had
Oh, that's what you trying to show me, Jess.
But you're like dead tired.
I don't know why.
All right. It's pretty obvious once you look at 14 what it was. Number 14 didn't have a hole in
It's
it, right?
an F.
So it's pretty obvious what it was. Now, this one here, again, we have to solve the following. So I think I'm going to need to take the 4 and move it over. You got to set it equal to 0 first. Anytime you have a quadratic, in order to solve it, you've got to set it equal to 0. So I'm going to put a -4 here, which will make this 0 on this side. I will now go ahead and factor. 2x and x. The only way I can get a -4 in the back is one's got to be positive and one's got to be negative, right? Plus and a minus. And I got 1 times 4 and 2 times 2. And what number can we eliminate? Which 2? Can we eliminate 2 and 2? Why?
It don't work.
Because there's no GCF. And if I put a 2 here, that creates a GCF. And so there is no GCF. So 2 and 2 is gone. And that makes for sure I can't put a 4 here, right? That makes a GCF as well. So there's only one scenario that is even possible. I got my signs. I guess my signs right. And so if I try and I multiply this together, I get -8 here, and I get a positive x here, which gives me the -7. So this is it. Now what? What's the next step? I got it factored. It's in intercept form. What are you going to do with each of the factors? Set them equal to 0. So I'm going to equal 0 here, so x is equal to 4. I'm going to set it equal to 0 here. I'm going to get 2x is equal to -1 because I'm going to subtract the 1 from both sides. I'm going to divide by 2, so x is equal to -1/2. So I have these two solutions.
Which makes it,
4 and -1/2. Woo! Where is the middle of that one?
between 1 and 2.
Between 1 and 2?
Oh, wait.
7/4.
Yeah,
So how'd you calculate that?
The distance is 400, so it's going to better that.
Correct. So the distance between these two here is 4 and 1/2, right? And so in this case here, then it's 2 and 1/4 is right in the middle. But it's 2 1/4 from this side or that side, which makes it kind of tough, right? So if I count over, maybe from the whole number, if I count over 2, right? And then I subtract 1/4. Puts me at 1 and 3/4. Is that right? Now I can't use mixed numbers. I have to write it as improper. So remember that 1 is really what? 4/4? And then 3/4 is still 3/4, and you just add that together, gives you a total of 7/4. Or you can multiply and then add, and that gives you that 7/4. So my axis of symmetry is 7/4. That's a pretty tough question. Is this the way you would want to solve this one? Is this the way you want to graph this one? Probably not. You know what I'm saying? It's probably not conducive for this one. So we get to complete the square here in a minute. Maybe transformations is better. Maybe. All right. So right here is your axis of symmetry. Well, my vertex is what? We said 7/4. Now what? What do you do with the 7/4? You gotta plug it in. Oh my gosh. This problem is horrid. Possibly. All right, now, guys, it's not too bad. In this case, we're gonna go 2 times 7/4. Yeah. 7/4 plus 1. It's in the little parentheses. And then I got 7/4 minus 4/1. I'll go ahead and set that one up. So I'm going to work with this one first. I'm going to manipulate this one first, and then I'll work with this one. So this one here, you can go ahead and multiply these together, which gives you what? 14, right? 14/4 plus 4/4 if you want to do it that way. Anybody have any questions on that? I went ahead and multiplied 2 times 7 gives you 14. And I changed the 1 to match up with the same denominator. So I get 18/4. What is 18/4? I think it's 9/2. Okay? Go ahead and simplify it. It'll help us out later. All right, this one here, I already set it up. All I have to do is find the common denominator. And that gives me minus 16. 7 minus 16. You know what that is? I have $7. I owe 16. I still owe $9. And that's over 4. And that's already simplified, so I can go ahead and put -9/4 here. And look how beautiful this is. -81/8. Gorgeous. Man. Why would Coach Love give a vertex that's not even pretty? Because almost all vertexes aren't critical. Okay? There are more fractional exponents or ones with square roots in them than to count. Okay? We can't count that. If you look at this as a 10 by 10 grid, right? There's an infinite number of points there, and all I can see is 100 points on the grids, right? That's all I've got. Those are your clean points. Everything else is insanely crazy. Okay? So that's why math is difficult for you guys. Does that make sense? Because you don't always get more nice points. Does that make sense? But in your reality, if you really think about it, you guys will probably deal with more of something we can deal with. Smaller. The hundreds, right? What you guys deal with the hundreds? Unless you're gas, but you deal with the thousands. Gas is like 107.999. It's really just $1.08. Okay. I don't know why they did that, but there's a reason. We can look it up, I'm sure. 8 goes into that almost 10 times, so it's going to be somewhere down here. Just make sure you do what? Label it. Go ahead and draw your parentheses. What's this point?
The one-liner shit.
And what is it?
0, -4.
All right, so I'm going to count that as 0, -4, even though it's not on that because I'm on my grid. Okay? I didn't scale it properly there. That's fine. All right? As long as I label it, I'm good. You're got a minimum here, and it is at -81/4 at x equals 7/4. My y-intercept, we went ahead and labeled that. If you want the sister point over here, I would have to double 7/4. We just don't worry about that. All right, now. Ready to complete the square? Actually, let me do this instead. Let's skip number 14. And I want to go to the Donald Duck problem.
Of course you put
I got to do at least one word problem, right?
No, you don't. You don't.
Oh, actually, yeah, I do. It's on the test. So we'll make sure we can do it. Donald Duck is getting ready to plow his garden. All right. The deer have gotten into his rectangular garden, eating his corn for the past 2 years. He's going to build a fence around it. All right. So he has 200 feet of fencing, which is not a lot of fencing, but he does have 200 feet. It's a small garden. All right. First thing we do is draw the fence. He wants how many pins? This one? All right. Draw your pin or your garden. There's your garden. All right. Label it. W, W. Cursive L, cursive L. That way I don't get cursed at for writing crazy L's. All right, now, once you have that, the perimeter is 2W plus 2L. Right? And the perimeter of a rectangle? What's the perimeter of this particular rectangle? How much? 200. Is correct. You got 200. Now we're looking for the area. Remember the formula for area? The rectangle?
Length times width.
Side times side, length times width. Okay. Now I have an L and a W, but I want to write it into either WW or LL. So I have to take this and write out one of them. Solve for W or L. I don't care which one. Solve for W. All right. We'll solve for W. So I messed up. That's supposed to be an L, by the way.
I was looking at it. I was like,
Yeah, I know. You were kind of looking at it. All right, now.
but I put it
So
down
I will
anyway.
subtract the 2L from this side over here. So I get 200 minus 2L equals 2W. Now I want what 1W is. What's 1W?
100 minus L.
Yeah, because you got to divide by 2. So it's 100 minus L is equal to W. You with me so far? So now we're going to take this. Instead of writing down the W, we're going to sub in. So I'm going to write down L parentheses 200 minus L. See that? Yes.
100.
Yes, correct. 100. All right, so remember, this is kind of like y is equal to x times 100 minus x. Okay? We have a parabola here. All right? This is it's gonna look like this. The parabola is gonna be flipped over. I kind of discussed this on the last one because in this case here, anybody know that is your x and that is your y, correct?
Mm-hmm.
What is the x represented in this problem? L. And what is your y? The area. Okay? So L is your length and your y will be your area, which would be your maximum area. So we're looking for our max area. All right? And we're also looking for the distance. So in this case, all I have to do is set these equal to 0 and solve. So L is equal to 0 and then L is equal to 100, correct? So if I'm graphing this parabola, here is 0 and here is 100. Okay? What do we do now? Once I have my 2 points, I have to draw what? How do you find your vertex? What are you going to do next? You have your 2 points in.
Go halves on axis symmetry.
Yeah, you go to the middle, right? So I got to draw the middle of this. The middle happens to be right here, guys. What's that distance? 50. So x is equal to 50. Or L, I should say. L is equal to 50. That's the AOS. That's your axis of symmetry, guys. So now I have 50, and so how do I find the area?
You plug it back into the W equation, where it's like 100 minus L.
You're going to plug it into this one right here. Okay? Because you know what your L is now, right? Your L is 50. So this is 50 times 100 minus 50. 50 times 50. 2500. That is your vertex. That's your vertex. That's the highest point on this parabola that we drew. Okay?
So would it be max?
So my length is, yes, my length is 50 feet. My max area is 2,500 feet area squared. All right? That's your square feet. And now I'm looking for my width. I need my dimensions. If I know that my length is 50, I can take that and I can plug it into my width equation, 100 minus 50. He just has to build a square fence, 50 by 50. Okay? Now, remember I said that we're not always going to end up with squares. our next one, I think, the next one that we have is not going to be in square. Okay. Now, I do have, in this case here, I will have to complete the square on this one tomorrow. So on number 14, we're going to do that one. All right, you guys are a little behind in this class. I may skip number 15 if it's, if you can try number 15 on your own, but I do want to complete the square on number 14. Attempt it and make sure you do your homework. 4.8 is in the packet I gave you on Monday. It is good. It's not a bad one. All right. Again, we'll have the quiz on Friday. The test is on November 11th, next Thursday. I know if you're in the band and you're not going to be here, you will have to make that up. It is an hour-long test. And make sure, guys, I will tell you right now, you cannot check any more calculators out from the library. It doesn't have any more. All right? Your batteries are dead. You can't always replace them. They'll replace the batteries in the calculator. You just have to take the calculator up there. If it's not working, they'll hopefully try to get it fixed. Remember, you cannot take a test. If I have a calculator apart, you have to have your own calculator. You cannot borrow calculators in here. And you cannot use your computer. Not all people actually have to be on your calculator on your computer.
For Monday.
What did you say?
I'll be there Wednesday, Thursday. But I think I'll let you down Friday.
Oh, that's right. We'll see how you feel. You might be back.
I'll not be back Thursday, but that's.
It's usually the third day.
I heard that, I'm kind of lucky to know like the first 2 weeks. So excited.
Yeah, it varies. It really varies. You may have an easy time. It won't be a problem.
Yeah, my brother got his out. I'm getting mine out a lot earlier than me. They're like clean. And like, yeah, but
Day 3 is really good.
So, isn't the UK currency like, she's saying that it's euros and it's not euros?
Yes, the euro.
Then what do they call like the coins and crap?
Well, they have the old English background, but euros are what's accepted all over Europe. So they
Yeah,
all.
because in England, I told you I had a British friend, and she was like, "Yeah, your shirt that I bought would be like
They have the quid they use and the pence, that was old English money before they went to Europe. Like in Italy, they have lira. Like you still exchange lira, but euros are really what they accept.
I always hear them talking about